The final type of research we'll explore is experimental research, which allows researchers to determine which of two or more groups improve the most after an intervention, and thus to determine whether an intervention itself actually works. Although this type of research is somewhat rarer in action research, it is possible to conduct a true experiment as part of an action research study. We'll discuss how. First, let's talk about the hallmarks of experimental studies. The most important aspect of experimental studies is the random assignment of participants to groups. In other words, groups are completely randomly formed at the start of the experiment, and participants have no influence on each other. The next hallmark is that the researcher manipulates at least one independent variable while controlling all other relevant variables. For example, a teacher could provide phone coaching on homework to one group of students, but not another. Everything else about the student's classroom experience would be the same. Next, differences between groups on the dependent variable are observed. We would expect that, if the intervention is effective, the group that received the intervention would perform differently from the group that did not receive the intervention. Note that experimental research is the only type of research that can test hypotheses to establish cause-effect relations. This is because of random assignment, control, and the presence of at least two groups. There are a few variations on the experimental design. In the first variation, participants are randomly assigned to one of two or more groups. Participants in both groups are then pre-tested. Next, some participants receive a treatment. Typically, the group that receives treatment is the experimental group, and the group that does not receive the treatment is called the control group. However, sometimes groups are comparison groups that receive alternative treatments. And note that treatment refers to some sort of intervention, not necessarily a treatment per se. Next, participants in both groups are post-tested. Changes in participant scores are compared for each group. If the treatment group that received the intervention changed more than the control group did, we conclude that the treatment was responsible for the difference. If the treatment group and the control group are no different after the treatment, we conclude that the intervention was not effective in bringing about greater change. A second variation on the experimental design involves eliminating the pretest. This is useful if there is a concern that a pretest will affect the post-test results. This version is less useful with small group sizes. This is because random assignment is less likely to do its job with small group sizes. In other words, the various alternative explanations for group differences that would normally be canceled out through random assignment can't be ruled out when groups are small. Thus, the lack of a pretest can make results confusing. Are post-test differences due to the treatment or due to pre-existing differences that weren't canceled out by random assignment? Therefore, as a rule of thumb, whenever possible, use a pretest. Although experimental designs do permit cause-effect conclusions, there are some drawbacks. Random assignment is often difficult for practical and/or ethical reasons. Furthermore, large sample sizes are desirable to help ensure that random assignment works. In addition, as experimental control increases, generalizability often decreases. Thus, experiments that are conducted in highly controlled, laboratory-like settings generally have less relevance for real-world settings. Nonetheless, experimental studies are possible in action research. Educators who want to compare two pedagogical approaches that can be implemented with individual students may choose to randomly assign students to one or the other approach, then compare students' growth. An especially appropriate use of experimental research is to test different technological applications, which can be delivered individually to students. Students could be randomly assigned to one of several applications that focus on the same skill to determine which application or program is most effective on average. When participants are post-tested only, no pretest, mean group scores on the post-test can be compared statistically to see which group performed better. With two groups, use students' t-test, unpaired. With more than two groups, use analysis of variance. Students' t-test, unpaired, compares two means from different groups. Analysis of variance is an extension of the t-test It examines whether there is a difference between at least two pairs of means when there are more than two means being compared. Here is an example of an experimental study that only uses a post-test. In this study of preschoolers randomly assigned to groups, the treatment group was exposed to letter recognition flashcards daily for 4 weeks. The control group was not exposed to flashcards during this time. All other aspects of their education were the same. The teacher then tested the students to see which group recognized more letters. The treatment group recognized a mean of 20 letters, whereas the control group recognized a mean of 10 letters, only half the amount that the treatment group recognized. If the t-test of this difference were significant, we would conclude that 4 weeks of flashcard exposure is effective for improving letter recognition in preschoolers. Note, however, 2 things. If the groups were very small, it is possible that random assignment didn't work, and that the treatment group started off with a higher level of letter recognition than the control group. This highlights the utility of a pretest. Second, the results can only be generalized to the population of preschoolers that the sample is representative of. If the preschoolers were not randomly sampled from the population, the teacher-researcher would need to be cautious in making general statements about the effectiveness of flashcards. Here is an extension of the previous experiment. In this study, there are 3 groups, all of which get exposure to flashcards. However, treatment A involves daily exposure, treatment B involves once a week exposure, and treatment C involves once every other week exposure. If the results of an analysis of variance of the 3 means were significant, this would suggest that daily exposure is more effective, and that there is not much difference between once a week and once every other week exposure. In this study, the researcher would need to follow up the analysis of variance, or ANOVA, by testing the difference between each pair of means with unpaired t-tests. This is because an ANOVA only indicates that a difference exists between at least 2 of the means. It doesn't say which means are different. A bit more complex analysis is used for a design that involves pre-testing and post-testing 2 or more groups. Although you can use 2 paired t-tests and associated effect size to compare the groups, a more precise analysis is a mixed analysis of variance, or ANOVA. This involves looking at whether one group's mean changed from pretest to post-test more than the other group's mean. This is a more complex analysis, but it is highly effective when sample sizes are large enough. Here is an example of a study that would use a mixed ANOVA to analyze the results. In this study, the treatment group, which received daily flashcards, represented with the blue line, and the control group, which did not receive flashcards, represented with the yellow line, were pre-tested and had the same level of pretest letter recognition, 10 letters on average. At post-test, the treatment group recognized an average of 24 letters, whereas the control group recognized an average of 12 letters. Although by looking at the graph, we can clearly see that the treatment group improved a lot, while the control group improved very little, we would still need to follow up with additional tests to make sure that our conclusions are accurate. This is because some data sets have statistical quirks that result in large differences between means not being significant and small differences between means being significant. This mostly has to do with the variability in each group. Regardless of which design and which test you use, remember that the results of the tests are presented with significance levels. The same convention, p less than or equal to 0.05, is used to reject or fail to reject the null hypothesis. When a t-test is significant, you just need to look at the means to see which group performed better than the other. However, when an ANOVA is significant, you will need to use additional tests to determine which means are different from each other. When only a post-test was given, test all possible combinations of pairs with t-tests, but make the p-value smaller for each test. When both a pretest and post-test were given, do a paired t-test comparing pretest to post-test for each group separately, and calculate effect size.